This tutorial is going to cover visual environment blueprints, which are used to control the overall look of the game, from color correction to post-processing and even the sky. As usual, I'll be working with Mirror's Edge Catalyst for this, and I imagine there will be some game-specific nuances here, but generally speaking, I think the principle should be the same across most games. So you can easily find visual environment blueprints by searching for type, visual environment blueprint. And some of the most important ones are these time of day ones, which are used to adjust the look of the game depending on what the current time is. If we look in the blueprint for the midday time of day, you can see that it kind of looks like blueprints we've seen before with components and property event connections. The components we have in here are all related to the game's visuals though, including post-processing like color correction and tone mapping, but also in-world entities like the sky and fog. If we look at this post effects visual environment, you can see that it has components for film grain, vignetting, motion blur, depth of field, a whole bunch of stuff. Aside from these very broad visual environments, you'll also have some which are specific to certain levels or even just areas of the game. For example, this Allcom interior VE changes the color correction, presumably when you're in certain Allcom buildings. This kind of implies then that multiple VEs can be active at the same time, and that's true. Each VE has this priority property, which determines which one gets the last say if two active VEs modify the same property. Now you might be thinking, do I really have to set the values for all of the properties in a component, even if I only want to override one? Now the answer is fortunately no. Each component has these property overrides and property override masks properties, which are used to declare which properties you want to change. Any properties not listed in these overrides won't have any effect, so you can just leave them default or set them to whatever. The property overrides are fairly obvious. It's just a list of the names of the properties. The override masks, however, are not so obvious. These are 32-bit bit fields, which basically list which properties are being overridden in order. If that doesn't make sense, don't worry. It doesn't have to, because I have made a tool that will help you to calculate these easily. A link for this is in the description as usual. In this tool, you can select from common VE components and then simply select which properties you want to override. And then you have your property override masks and property overrides in this section on the left. If your component isn't listed in these common options, you can import a VE blueprint from an XML file. You can get an XML file for a VE blueprint either from an XML dump if you already have one, or you can use the editor to export your specific blueprint by right-clicking on it in the Data Explorer, clicking Export, selecting XML as the file type and clicking Save. When you import an XML file, it will also automatically read the existing overrides from the file and then pre-select them for you, which is handy if you're modifying an existing VE component rather than making a new one. Then, once you've made your changes, you can just copy and paste the values back into Frosty. So, for a demo, let's change this hue property in the noon time of day VE. So I've already imported the XML file for this particular VE, so we just need to enable the hue override. Then we can copy the property override mask across and add hue to the property overrides, and now we can change this. Let's change this to something crazy like 180 degrees, because that will be very obvious. And then we can launch the game and see how it looks. Well, it looks pretty disgusting, to be honest, but at least we can tell that it worked. Before I end the video, I want to talk about the sky components quickly, because they're actually really cool. The sky in Mirror's Edge Catalyst is actually physically based, meaning that rather than using a traditional skybox or texture, the sky is actually simulated using real physical properties such as Rayleigh scattering. This means you can actually theoretically make the atmosphere look like a different planet if you want. And it also impacts the game's whole lighting dynamically, which is really cool. This is basically how I made the Better Skies mod, as well as the Mars Atmosphere and Aesthetic mods. If you're interested in modifying the PBR sky, I'll link some great dev talks which explain a lot of the systems a fair bit, as they make a lot of the properties in here make a lot more sense, so I highly recommend checking those out. Anyway, I know this video has been kind of short compared to my others, but there's not really much complicated to explain in here besides the property overrides, so I mostly just wanted to explain those.